All right. All right, we've got enough people to start. Welcome to this month's CDM. We've got the topic or the agenda is shared in the chat there. The first topic is from Ken. Take it away, Ken.
All right. Hey, everybody. My name is Ken Dreyer, and I've been a developer on the Ceph project for a while. Um, my focus is on the operating system and the packaging, the build system. My role has changed a little bit over the years, but for our presentation today, I'm going to be talking about Apple 10 and enabling Ceph on the latest version of Enterprise Linux. So I'm going to go ahead and share my screen. All right. Hopefully everybody can see the presentation here.
I don't see it yet.
Oh, okay.
Oh, there it is. There's just a delay.
Okay. All right. Well, hopefully I'm going to go ahead and talk, and we'll go through the slides as they go. I have seen that delay on Jitsi as well before, but I guess we'll go through it here, and I can definitely post the slides as well after CDM. So the goals for what I want to talk about today are understanding Apple, like what it is, how does it fit into the enterprise Linux ecosystem, and then also scope out the work to enable Ceph on that platform as the primary platform, and talk about what that means and how do we get there. So when it comes to enterprise Linux, Red Hat has this Red Hat Enterprise Linux operating system, and the way that that's constructed goes through a variety of steps. There's a bunch of open source projects. Those end up getting packaged into the Fedora Linux project, and then from there, that ends up getting copied. The Red Hat engineers take that and put those packages into CentOS Stream, and then that eventually becomes Red Hat Enterprise Linux. So this process is pretty new. If you have been around for a while, you know that before CentOS Stream came out, there was like a different process where Fedora got forked and put into Red Hat Enterprise Linux, and then the CentOS project took that and rebuilt what was in Enterprise Linux. And then Red Hat made a change here with the CentOS project that um, you know Fedora essentially is the upstream to CentOS Stream, and then CentOS Stream ends up getting forked into RHEL, and then also some other derivative distributions. Like in this slide, you can see the Alma Linux project as well pulls from CentOS Stream um, as well. So that covers what the enterprise Linux ecosystem is. How is Jitsi doing in terms of keeping up with the presentation so far?
It's totally fine for me. There was just the lag in the initial, when you've only started sharing your screen, but it's fine now.
Okay, perfect. That's great. Okay, so Apple is basically a layer on top of the enterprise Linux distribution. So in enterprise Linux, you can imagine Red Hat, ships the packages that are important to their customers. But when you look at some of these more upstream projects, like Fedora has a very large amount of packages in it. RHEL, by comparison, has a pretty small package set. And if you've ever used RHEL, then as you know, like RHEL often lacks the packages that we need for Ceph, and thereby the derivatives as well. And so Apple gives us a place to promote, support, and benefit the packages that exist in Fedora, but Red Hat did not choose to ship for whatever reason. Um, so the next couple of slides, I'm going to talk about like what Apple is and how does it work. Um, if you want to get a package into Apple, there's a document in the Fedora docs for this. Oh, and like I said earlier, that this is hosted in the Fedora project, but it is for enterprise Linux. So Apple itself never runs on Fedora. You wouldn't enable Apple on your Fedora system. It is basically a project that sits within the Fedora project in organization only there. So if you propose a package, and ask for it from the existing maintainers, and they say no or they don't respond, you can definitely start by becoming a Fedora packager yourself. and that allows you to maintain the package for Apple. And actually, this is my story of how I got started in the Fedora community. Was I was a system administrator and I needed some package in Apple that I was maintaining in my own organization, and I decided it would be simpler if I just went ahead and maintained it for Apple. Um, and then down the rabbit hole I fell basically. So if you can't do packaging, you can still help, and that is the Apple uses Fedora's update system that's called Bodhi right here. And this is a system, it's a platform that allows us to gate updates and sort of crowdsource the testing there. So you can log into the system. Basically, it starts with you running like the testing repository on your systems. Um, and you can pull down packages from this repository that's not enabled by default, and then you can give like a thumbs up or a thumbs down to a particular update that's about to ship. So it's very open, like QA process, and a pretty neat workflow there. So that covers Apple. I wanted to go over now like how does Ceph use Apple, and what do we use? There's a lot of runtime dependencies, and there's a lot more dependencies at build time. This slide has the runtime ones. You can see some of these libraries are pretty low level. They're libraries that Red Hat chose not to ship in RHEL for whatever reason. Um, and this bullet point in particular, there's actually 35 Python libraries that get expanded out in there. You can think of like async SSH as the SSH library that Ceph ADM uses, for example. So where is Enterprise Linux 10? What's the state of the world there? So CentOS Stream 10 is actually available for early development, and you can actually pull the container this way. I've been doing that this week, and I've mentioned some more results about that later. For Alma 10 as well, they have shipped a snapshot of what they picture the future of their release being. This is very early release. It's codenamed Kitten, I think. And that is available. And then, of course, RHEL, is coming in the future. But another important point here is that Apple 10 is also enabled pretty early as well for packagers to ship their stuff in there. A little bit more about what is coming in EL10. If you fire up that CentOS 10 container or Alma Linux container, you're going to find GCC 14, which is great. I know Casey and others have been talking about upgrading to that version for a while for Ceph. Here's the kernel version that we're shipping, and then of course Python 3.12. Kind of the standard updates here. So the next process I'm going to talk about is like, how have I done this in the past? So in the past, I went through this process for like bringing up EL8 and then EL9. This is basically how I've done it: is you set up the environment, you run install deps.sh, or another option is you can take the source RPM and rebuild that. But basically, what you want to do is build out that list of missing packages, package them. I put in italics because it's like a small matter of packaging, right? But usually, what I do is I end up forking from Fedora Rawhide here, and then just go through that step process over and over until you get all of the packages all set up. So that's like a good way to do it on your workstation, but then sharing with the world. If you go to this GitHub link, you can see what I did for EL9 here, and this kind of walks through what were the steps, how did I fork the packages, how did I build out that list, and so on. And this system is called Copper. So Fedora has something that's really similar. If you know Ubuntu's PPAs, it's like a package, sort of like an add-on thing that gives you a little bit more flexibility around how you build and deliver RPMs. And so in Fedora, we ended up setting up like a Ceph EL9 one to deliver all the RPMs while we're still feeding them into Apple slowly, because sometimes it takes different reasons for, or it can take different time for a variety of reasons. Some of it comes down to like that gating process earlier that I mentioned with Bodhi, but sometimes there's things that we have to work out with the maintainers as well. So that this is kind of the workflow. It basically develop it first on your local computer, then put it up into Fedora Copper. That takes only a few minutes to go from here to here. But sometimes getting things, like I said, into Apple can take a few days or weeks to go there. So I'll pause here. Does anybody have any questions about Apple specifically? Okay, cool. So yeah, I'm going to go ahead and talk about Ceph on EL10 beyond Apple. So I think historically, some of the problems that I've found were that doing all of that packaging process does not get us all the way through getting Ceph onto the next like major enterprise Linux release. So in the next couple slides, I scoped out more of like what that involves. So the next couple things I want to talk about are the CentOS storage SIG, where we get NFS Ganesha today. Some of the Ceph integration bugs, these are kind of the hidden things that we find more towards the end once all the dependencies are in place. Getting EL10 into the Ceph lab, container file adjustments, and then Topology. So the CentOS storage SIG is sort of like a little bit of a parallel universe. This is a system that CentOS had set up a long time ago where they wanted more um, projects to be able to build into their community build system. And so they have, you know, a lot of people that understand packaging. There's a wiki for documentation. This is like an alternative to Apple, essentially. It doesn't have the Bodhi gating system, but it does give you a lot of flexibility and control. So Apple has some guidelines, for example, that you can't overwrite packages that exist in RHEL, and then in the CentOS SIG model, there's like um, no such guideline. Like you can put kind of whatever you want into there, different kernels or compilers or whatever you want. Um, so as you can imagine, that's like a flexibility complexity trade-off there. One piece to call out is that NFS Ganesha actually comes from here. So if you look in the container file that we use to build Ceph, we actually pull NFS Ganesha directly from there. Um, so I think that Caleb Keithley has done quite a bit of work in this area, and I think this would be a great area for like future collaboration. So the next piece is Ceph integration bugs for EL10. So I have not really gotten far on this yet because I have not looked up like all of the dependency issues. Today I actually found out that Caleb was able to build Ceph on EL10 in the CentOS storage SIG. Um, I think that's like as of a few hours ago. So that's really great news. I know that there's going to be some of these integration bugs as they come up. So this work is going to be stuff that we have to scope out here. This OpenSSL API change is something that came out of the RHEL OpenSSL maintainers have asked us to change some of the ways that we're linking and or building against OpenSSL, I guess. Um, but I think that that change may or may not impact Ceph. So then, of course, like we get further into integration here. So we have all of the Sepia lab is managed with a system called Fog for OS provisioning, and that allows us to like stream images onto bare metal. So we're going to need some Fog administrator work here to get like snapshots of the operating system, put into Fog, and then be able to deploy it on old hardware or on new hardware, I should say, because the old hardware um, some of it does not work with CentOS Stream 10, actually, because they've decided to compile with this flag that basically if you have a very old CPU, like the system I was testing on was about 10 years old, and it looked like you get this error basically as soon as you fire up the container, it's going to say CPU does not support v3 here. So interestingly, Alma Linux 10 has decided to diverge from RHEL here, and they ended up reversing that requirement. So I thought that was interesting to note. Next up, we have the container file. So as if you go look in Ceph, this is a pretty recent addition. Under the container directory, you're going to find a container file here. This is still like a work in progress, and I don't think the release builds are built from this yet. But this is definitely the direction that the project is heading, is embedding the container file directly into Ceph.kit. And you can see the very first line in there has Quay.io, CentOS, CentOS Stream 9. So one of my goals is to get that 9 up to 10. And then lastly, this slide talks about testing in Teuthology. This is something that I definitely am very much a newbie at. I know that the test suites inside the Ceph tree are a series of YAML files and symlinks, and many of them hard code, like distro versions, or there's also like lists of distro versions that we'll need to add EL10 into there. And so that wraps up the presentation.
Thanks, Ken. That was really comprehensive. I think one thing to add to this whole workflow about if we're talking about just introducing CentOS 10 is the whole container workflow with key.ceph.io. That's one thing to consider as well.
Yeah, what kind of details are you thinking about there, Laura?
So that it's kind of that would be a conversation where Dan might have more details than I do, but that plays into how we test it on Teuthology. So there's the building packages part, but then every time packages are built for the CentOS 8 distributions, we also push containers to key.ceph.io, and that's an important part of what we do for the daily shaman builds, as well as eventually releasing Ceph upstream. So there's basically there would need to be some uh, work done to add that into the Ceph container code. So we can talk about that more, like maybe in the infrastructure call, like what that would mean. But that's an additional step into. I would add that along with changing the Teuthology symlinks.
Okay. Okay, so kind of more down towards the end here, you're saying ensuring that this works on key.ceph.io.
Right. Yeah. John's saying some been messaging too. I think in the past, Dan noted that the images don't distinguish between base OS version, so it's hard to control what is being tested. Yeah, and oh, God, was somebody gonna say something?
Yeah, just going the container file change. If we bump that from 9 to 10, then will we be building any CentOS 9 containers to worry about in Key? Or will we just be testing EL10 containers when we're doing main testing?
Yeah. What do you recommend there, Casey?
Bumping to 10 and supporting just that for the next release.
Yeah, I would agree with that. All right. Well, did anybody have any other questions?
I'd noticed that you mentioned Alma a couple of times on your slides, and I'm curious what you think about trying to use that for upstream CI instead of CentOS.
Yeah, this slide in particular here, this is an interesting one because CentOS stream, what you're going to find is that the development process is faster here, but Alma is going to be longer lived. So the other, piece too to consider in terms of the trade-off is there's going to be more developers probably working on this, as opposed to Alma's pretty small team. But I think the trade-off there again is like back in the old times, I think CentOS was really only run by a very few number of people and had an insane level of user base there. Um, so, there's trade-offs here for sure. But I do think that it would be interesting to look into using Alma here.
Yeah, the main pain point with CentOS streams is that they just stop working at EOL, and my understanding is that Alma and Raki, I think, continue getting security updates for an extra 5 years.
Yeah, that's my understanding too. Yeah, I think it's a good sign of health that, like I mentioned down below here, that Alma has already released like a 10 version. I don't know how often they're going to be updating this. I know this is getting revved a lot. Um, I think maybe they did this as sort of like a beta version, basically, especially since that Red Hat is no longer doing betas for their point releases. I think they were stepping into the gap there to try to fill that. Did anybody have any other questions?
Unfortunately, I had to join late. Can you share the slides somewhere?
Yeah, definitely. I'll put these slides up on the CDM wiki page for November of 2024.
Thanks, Ken. All right. So our next topic is from Yehuda about our GW bucket level snapshots.
Hi, my name is Yehuda Sadeh-Weinraub. Also, been contributing to Ceph for a while. Let's see, trying to add presentation. Can you see that?
Yep.
Yes.
All right. So the idea of snapshot of RGW buckets is not really new. Like we discussed it, I remember, in 2010. And originally the discussion was about how to leverage Rados snapshots for use for RGW. But one of the main points we had was like we didn't really have a use for that. It looks like the feeling is that we do actually have use for bucket snapshots, and that's one thing. But on the other hand, it's not clear that we want to use Rados level constructs for that. Rados snapshots that RBD is using and SFFS. So some of the motivation, for example, we were looking at, I don't know, there are people upstream, downstream, different areas looking for getting backups of RGW buckets. There are mechanisms within RGW that provides some kind of disaster recovery. There's multi-site, there's an archive zone, but that's not really backup because the backup also includes the ability to restore the data and the ability to restore the data in a meaningful way, like a point in time consistent state, or ability to look at different snapshots of the bucket state in different points in time, which is not really something that we can provide. The Ceph, or no, the AWS S3 bucket versioning allows you to keep every version of every object, but it's like in the context of that specific object. So you might have like 20,000 versions of a single object, and only like 3 versions of a different object. And in order to figure out application consistent state, you need to then start looking at timestamps, and that's not really friendly. There are mechanisms that are currently being put in place to provide support for backup. I know Yuval Lipschitz has been working on that by leveraging activity logs. That's not the perfect solution for backup. There is some issues with in the way that RGW is doing its right. The activity logs are like either pre-object creation or post-object creations, and then there are atomicity issues, and it's very hard to get point in time. You can only do that if bucket versioning was enabled, and even then, there are issues like object versions might be removed, and you can. So to make things short, there are issues with that. It's not perfect. Now, I can go briefly over how actually what the S3 object model and how it works. On the left side, there are like sequence of operations on multiple objects. And on the right side, the diagram shows what would be the end result after these operations. So we put an object A, B, C, D, put A, B, C, delete B, put D, put C twice again. You end up in the non-version object version. In the non-version bucket case, you end up with 3 objects, A, C, and D at the end. The versioned case is a bit more complicated. Is compatible with the AWS S3 versioning. There are also Swift versions, but I'm not talking about that. Sorry, here. That's the version case where the same sequence of operation, you'd end up with 7 different entries in the bucket index, 6 of them actually of object instances, and 1 of them is a delete marker. So you have all the history there. Now, in this example, I showed that leveraging activity logs basically is not perfect, because you can't really know when the backup started, when it ended. So what you're gonna have is like some kind of a version of the bucket through the operation, not necessarily. In the versioned case, when doing backup, the situation is better but not perfect, because in version case you'd have the ability to look at all the versions that were created up until when the backup ended. Okay, so what I'm proposing, I'm talking about bucket snapshots, and I look at the version case first. Bucket snapshots, a system that's based on the RGW versioning system, subsystem. So it's not really going to be based on the Rados version, Rados snapshots. And the reason is that we don't need to use the Rados snapshot is that it gives us very little, because RGW already maintains the underlying object versions, and all the needed capabilities that most of the needed capabilities that Rados snapshots giving us, but Redis snapshot has some issues that we probably want to avoid, like all the different versions of a specific Redis object are going to be all on the same PG next to the same version, and that's not good for data distribution. The issue of accounting. There are other issues. It's more complicated to implement, probably. So what I'm suggesting is that we keep a snapshot ID on the bucket itself, on the bucket metadata, or the bucket instance object. And whenever user initiates a snapshot, we increase that snapshot ID. Every object that is written, every object version instance that is written is gonna have the snapshot ID that for that specific bucket when it was created. This is going to be transferred to the bucket index, where we're going to maintain some kind of mechanism that would allow us to do listing of the bucket based on specific version ID, so based on specific snapshot ID. So for example, we want snapshot 1, it's going to either give us all the entries that we're creating during snapshot 1, or will give us the complete state of the bucket when snapshot 1 was taken. Or snapshot 2 in this case is a better example, because snapshot 2 would have the two views would be different. Can look at the operations and sequence operations here. So for example, in the same sequence of operations that I described earlier, when taking snapshot 1, we can list of snapshot 1, it will give us object ABC. When listing snapshot 2, it would either give us all the objects that were created when snapshot 2 with all the version history of what happened when snapshot 2 was created, or just what happened between 1 and 2. So let's see what else I had to say here. Yeah, that basically continuing the same points. There are more into it, but that's the idea at large. The non-version case is a bit different in way that it still would need to be based on the versioning system. So in this case, I see a couple of options. Is one, don't allow non-versioned buckets to be snapshotted. Another one, treat it as a suspended version case, which I think probably makes more sense. There are some issues that would need to be figured, like technically how to do it, because now you might have, for the same object and the same object ID, different instances of the same object. So we need to, for example, because the object ID in this case is null, object A might have a version that existed when snapshot 1 was taken, a version that existed when snapshot 2 was taken, and technically, because it's non-versioned, the versions are the same, which are null. So we need to manage that. Now, don't go here on the complete technical details of how to implement the bucket index, but the thinking is that there are going to be two new things here, at least two. One, in order to be able to present the snapshots, one is we'd keep another namespace in the bucket index that would represent all the snapshots, all the objects that in a specific that were created in a or modified in a specific snapshot ID, so that if you want to list those, we can list those without needing to go over the entire index. And then there's going to be a mechanism that allows you to efficiently scan through the index to be able to look at the index state when a specific snapshot was taken, which is different because you'd have objects from a different from previous snapshots too. The OLH log should be now able to leverage the snapshot ID and create the OLH, which is the object logical head, which is the entry that points. It's kind of like a link, soft link. Would need to be able to point into the correct object version in this situation, and the changes would need to happen to the OLH itself, so that we could do operations like removal of snapshots, so that it could then go back in time and find the object versions in a specific snapshot. Like if you took a snapshot 1, 2, 3, but there was 1, 2, 3, 4, let's say, and the object was modified during snapshot 1, during snapshot 3, and we remove now snapshot 3. So when looking at the object during snapshot 4, it still needs to exist, but when removing 4, it needs to revert to what was there at 1. So there's a whole logic that needs to happen there too. I'll stop for a second. Any questions?
Maybe like it's more into the details, but I was wondering how you can have a two sets of bucket index, one indexed, one is the current one, and one has also the snapshot as a key, or do you plan
it's not really, yeah, pretty much, right? So we'd have an extra entry per object now. If currently for a version object, we keep at least one entry for the OLH and 2 entries for each object. And then there are cases where there's an extra entry. Then now we'd keep 3 entries per in the snap if we are using snapshots. Now we're gonna keep 3 entries, but it's not the whole story. But yeah, we're gonna be.
Okay, so you're gonna add more entries, but you're not gonna have a different set. So if you want to kind of go over a specific snapshot, you need to go through the entire, like all the bucket index, and just fetch the right one for all the objects.
Depending what you want to find, right? If you wanted to get only the objects that were modified during a specific snapshot, you'd have the namespace, right, based on the snapshot ID as you suggested, in which case you don't need to go over everything. Now, if you want to look at the state of the bucket during a specific snapshot, there are two options here. One is, yes, go over all the entries. And two, and that's a mechanism that I suggested offline, is a mechanism that would allow us to do it without going over all the entries. There will be, for each entry that we keep, it'll all, like in the regular index, it'll also have a pointer forward to the next entry that is on a lower snapshot.
Okay, thanks.
So that would allow us to do a, skip to the next one. Any other questions?
So you just mentioned that for version buckets, whenever we delete a snapshot, it might affect the OLH for a specific object if that object happens to be part of that snapshot, right?
Right.
And so we'd have to update the OLH to
Yeah.
reflect. Okay, so when we delete, let's say we have two snapshots, we delete snapshot 2, then, and for a specific object A, let's say the OLH is pointing at the version that is in snapshot 2. Once we delete snapshot 2, what's going to happen to OLH? It's going to point to the previous snapshot? Or
Well, we'll know the state of which snapshots exist at the bucket level also, which I didn't mention it here. So we can take that state that says snapshot 1 exists, snapshot 2 does not exist. And when reading the OLH, even without modifying it, we'll know that we now need to go to snapshot 1. That's one thing. There is going to be asynchronous process that would go and do the modifications and normalization of the OLHs.
okay, in the background. Something like that.
Yeah.
Once we remove the snapshot. Okay. And follow up, let's say that there is an object version that sits between snapshot 2 and snapshot 1.
Yeah.
If you delete
right. Sorry.
I don't know if I'm getting into too much detail, so let me know if I do. But I was just curious.
Or between snapshot 1 and snapshot 3 or something.
Yeah, so if there is a version that is not part of any snapshot,
right,
then the OLH theoretically should just point to it.
Yeah, the OLH is gonna have history of the different instances and when they were created, and it should be able to identify that.
Okay.
Now we should be how that is going to be implemented. There's considerations of how well that can scale, and we can put limits on no more than 1,000 snapshots, for example, per bucket or something, or or per. But I'd rather not do that. But we need to consider the implementation. Would need to consider that.
Okay, makes sense.
For example, the OLH itself could be like just a cache of over 100 instances, but whoever keeps the actual truth is the bucket index, which is the case with object versioning. And so in that case, it's gonna, see, okay, I only have the information for these snapshots. So I'm gonna fetch the information from the bucket index and then do it. So it should be able to scale a bit better. Other things that will need to be modified is bucket resharding. But that's depending on whether we do that lookup that I mentioned to Yuval, because system is based on that you never have an entry that is suddenly created at an older snapshot, which there are mechanisms to also allow that, but I don't want to dive too much into the details there because it's gonna still, in the design phase. But I think, we'll need to consider resharding, and we'll need to consider the case where if you want to write objects of older snapshots, how that should be handled in order to maintain the correct structures.
Okay.
I think that's pretty much. Let's see if there's anything interesting. Back up. Yeah, that's been pretty much it. Any other questions? Comments?
I do think that the OLH for versioning is a really nice way to do redirects based on the snapshot requested.
Yeah, I think that would be the simpler way to implement that. It's gonna build for it.
Implementing all of the bucket index stuff sounds complicated.
It does.
And it seems like just listing the current version will have to potentially skip a lot of entries that were deleted from earlier snapshots. So I might be concerned about performance of listing in general there.
Listing the current version. What do you mean?
Say that you had an old snapshot with a bunch of things in it that were deleted since,
Right.
and you're trying to list the current bucket, like a list object versions request. I assume it's going to have to scan all of the snapshot versions as well and skip them, or is there a way to avoid that?
Well, the system that I described, where you have every entry points at an entry that follows it with a lesser snapshot ID, should mostly cover that, I think. But there can be other optimizations that we can do. Maybe keep in mind that we have a secondary index per snapshot, right? So we can see if we can leverage that to not require to go over all the all the entries in the index. What I proposed for the entry that skips to one that's lesser than that. So let's say you want to list the state at snapshot 4, and you're already at 7. So you start with listing in the beginning, and you get entry that is at 7. It's pointed something that might be at 6 or at 5. You go to that. You continue until you found one that is at 4. So that's like O log n. And then the next one would be, you start reading and you get a 4, a 4, a 4, a 4, a 3, a 4, a 4, and then suddenly an 8, right? Or a 7. So now you skip again until you find the next one that is a 4. So you don't need to read everything. You just need to skip as long as, Is that kind of clear?
I mean, I think that helps with when you're requesting a listing of an older snapshot, but I don't see how it avoids scanning everything for listing the current version.
Listing the current version, we're going to keep just the changes that happen at the current version? You mean?
No, just like sending a list object versions on the bucket that's
just
supposed to list all of the stuff that's currently there.
You just list everything. We're not gonna. You mean, yeah, what happens because we still have versions that are kind of removed. Yeah. We can always keep yeah, we need to think about that a bit, but keep in mind, and you're talking about the case where we remove a snapshot altogether.
That or just deleted a bunch of entries that were in a previous snapshot.
Right. Yeah. Yeah, we need to figure out how to represent that in a way that would be more more efficient, let's say that.
Or maybe that's just a performance implication of enabling snapshots.
Could definitely be. Like the idea is, right, we're keeping it in line there, right? So I'm not sure there's a way to go around that, but we can have like an out of bounds process that goes over, like for example, when the we have something that goes over the index when a snapshot was removed to do the cleanup, so it can put like hints in the index while it's doing it. Could that make things better? Like if it scans already the whole index when after the snapshot was removed in order to perform, the cleanup. Does that make sense?
As long as it's able to retire the index entries that we would have to scan over, then yeah. I like the idea of lifecycle policy extensions also.
Mm-hmm. Yeah.
And
I didn't mention that.
Maybe setting up something to just transition snapshots somewhere else would just get them out of the bucket and make it perform better overall.
Right. There's the idea of transitioning snapshots outside. There's also, I don't know if I mentioned before, doing it like in a multi-site based or something based on snapshots, policy. And there are different options what we can do with that. That's all I had.
All right. Any more questions for this topic? All right. Thanks, Yehuda. If you can, would you be able to share the slides and we can link them on the agenda?
Yes, I will.
Thanks, Yehuda.
Thanks.
All right. That's the last topic on our agenda, so we'll conclude for today. Thanks, Ken and Yehuda, for your presentations. And I'll see you all in the next months. So just I'll say for next month, we do have an EMEA session scheduled, but it likely won't occur due to Suffocon conflicts. So look for updates on that. But we'll see you all in the next few months. Have a good day, everybody.
Hey, thanks a lot, Laura.
Bye.